Water helps the environment, and healthy streams will help the environment.
It's like a food chain for real, like without one thing, it leads to another.
Since we don't have a lot of drinkable water, if the streams aren't taken care of, then we ain't got nothing to drink.
A macroinvertebrate is an aquatic organism that is big enough to be seen with the naked eye. An invertebrate means that it doesn't have a backbone. And the reason we care about macroinvertebrates so much is they really give us an excellent window into the water quality of our rivers, lakes, and streams. A lot of people think that you need to have a lot of fancy equipment to go out and test water. The reality of it is that equipment is very important and very helpful, but a really excellent way of assessing the water quality in your rivers, lakes, and streams in your community is to basically just see what's living in them.
Stream health is really dependent on several factors. The habitat is by far the most important, and that isn't just the habitat within the stream bed. It also includes everything that's within what we would call the watershed, and that's any land that drains into that stream. If there's an area that's been completely cleared of trees or grasslands, that's going to affect the entire stream to some degree. If a stream is straightened into a ditch, it's going to be less usable to the species that are there. What you can learn by the community of fish in a stream is certain fish are what we would call indicators of good water quality. And what that means is that certain fish would only live in an area that's very, very clean of pollutants or siltation, because either their insect food would need clean water or their eggs need a very specific water quality. So by finding those fish, you know that it's a very good area. Also, if you only find fish that can tolerate really bad water quality, then that is a big red flag that something's going on in the stream or the watershed. Electrofishing is a form of sampling that we use. A generator produces an electrical current, and then it pulses it very rapidly into the water. And by doing so, it creates a field, and any fish that enters that field will literally be drawn up to the probes where the electricity is coming out, and it will stun them. It very, very rarely is fatal to them. Once we've collected a fish, we will split them into all the different species, and then we'll get weights, lengths if we need to, also check them for just physical health, and then return them as quickly as possible to the stream. There are many different ways that people can help keep a stream clean. Everything from picking up litter that someone else has left behind or the stream is washed down, to just using good land practices or safe application of chemicals on a lawn at the right time of year. These are all things that eventually will help improve stream quality.
Nature cleans water through the water cycle.
It filters it through the soil, like it just runs all the way down, like it filters it through the water cycle.
It goes through a cycle and it's clean.
The main reason that not everybody would use a sewer system is that they don't live close enough to a large city where they have treatment plants. A septic system environmentally is the best way that there is to handle septic waste. It eventually goes out to the soil and works into the nutrients and stuff there, because the soil that was put here on Earth is actually the best filter we have for the septic waste. We have some systems in Indian Hill, it's called drip irrigation, and what they are is an on-site type system. Your sewage comes out of your house into the tanks, it's aerated, and then it goes into a dose chamber, and they have pressure lines that the effluent from the septic is pumped out to, and then it's filtered down through the ground. The advantages of a drip irrigation system is that none of the wastewater leaves your property, therefore you're not polluting waterways or having water run off to your neighbors. Mound systems are a little different type of a system than a drip. Your effluent flows to tanks, and then it's usually time dosed or demand dosed to a raised mound system, which is built out of sand and dirt, especially in areas where the soil cannot absorb. And this also is an on-site type system that helps keep the effluent from running onto watercourses. Aeration systems, a type of system that does discharge. If the system has been maintained properly, if you see a pipe that's coming out of a septic system, it's relatively clean, acceptable discharge that can go to a water course, but it's still not the type of thing you would want to drink out of.
Brailleville is on a 300-acre farm located outside the city. Our constructed wetland was a project that we undertook because we had a problem. We had failing septic systems, and failing septic systems pollute. We had a stream that was getting polluted from one of our failures. Septic tanks and leach fields are part of traditional septic systems. We have a wetland in between, and the wetland treats the water to a certain level of cleanliness before it goes into the leach field. The wetland cell is like a big hole in the ground that is only 2 feet deep. It has a liner at the bottom, and it's filled with gravel, and the wastewater goes through this gravel. The microorganisms live on the gravel and live on the roots of the plants that are in the wetland, and they treat the wastewater. The University of Cincinnati and US EPA have been researching our wetland since it was put in. When we put it in, they helped to set it up so that it could be used as a sort of laboratory for experiments. They did a recirculation study where some of the channels were recirculated and others weren't. They were kept as a control to see how much difference that would make to the treatment of the water. A second study involved looking at pathogens. There's a third study going on that has to do with chemicals. Chemicals coming in from medications that people take, from household cleaners, from washing detergents, and that sort of thing. Water is a precious resource. The amount of water on the earth is pretty substantial, but most of that is not readily usable. And as we use the water, we pollute it. But nature has its own cycles for cleaning it up. So we don't want to pollute the water to the point where it can't be utilized. Water is going to become scarcer and scarcer as there are more and more demands on water. And so it's something we really need to care about.
Well, humans have a lot of effect on water.
We pollute it, we do all types of nasty stuff to the water.
Chemical waste and all the stuff people throw in the water.
I don't think we have.
Here in Cincinnati, there's just been a strong interest and a growing interest among citizens and environmental professionals about how we manage our stormwater. The interest is in people being concerned about how we're treating our water systems. And while we have a very safe system, we have safe drinking water, and wastewater treatment systems are excellent, there's a recognition of the environmental quality and preserving the natural functioning of the environment and the ecosystem services that we depend on. And so just having the safe and clean water is not enough anymore. We're moving to where we want to preserve and to restore the natural functioning of the water cycle. The rainwater that falls on our lawns and our roofs and our streets picks up everything in its path. So basically, anything that's on the ground can end up in our stormwater and in our creeks and eventually onto the bigger rivers. The Mill Creek watershed combines parts of Hamilton County and Butler County and contains the entire land area where rainwater that falls on that land will eventually find its way to the Mill Creek and then to the Ohio River.
The city of Cincinnati is so prosperous because it had Mill Creek. All the businesses and industries came in and settled right along the creek so they could dump their waste in there. Originally that wasn't a problem because that's what everybody did, was dump their waste into the streams. But now that we know that that's not a good idea and we know ways to prevent that, there's ways that we can clean up the stream and improve the water quality. The Mill Creek Restoration Project was started because of the long history of abuse to Mill Creek. We were started originally to create an education program for middle school and high school students in the Cincinnati area. And our biggest goal is creating sustainability in the watershed and creating future leaders in the community that can help bring awareness to Mill Creek and help get it cleaned up and improve the water quality. So we have water quality monitoring. Schools will go out in the fall and the spring, and they can compare the different seasons, they compare different sites in the watershed, so they actually do hands-on monitoring with the field test kids. We want to encourage them to learn about the environment and take that with them to involve action taking, so that they're not just sitting in the classroom and learning about the issues, they're involved out in the field, learning about what's affecting their watershed and how they can help it.
Toxic chemicals are still a problem in the Mill Creek, but not nearly as much as it used to be because of the passage of the Clean Water Act in the early 70s. Large industries are no longer discharging the hazardous waste to the Mill Creek that they used to do. What bad stuff is in the Mill Creek? I'd say the number one threat would be high bacteria levels when you have the sewer overflows, because that can ruin your health. Beyond that, I'd say it's the nutrients from fertilizers, because when you get too many nutrients, you get algae blooms and then you get fish kills, and that's a stinking mess. When we go canoeing on the Mill Creek, we'll see kids playing along the creek, and they don't know about the high bacteria levels. They don't know about the sewer overflows. They're just kids playing in the creek. I mean, it's hard to keep kids away from the water. So I feel like that's a really important mission, to at least make it so that the Mill Creek isn't a public health threat.
The problem with the Mill Creek and other urban streams, it's really a matter of impervious surface and what I call peak discharge with rain events. These peak events degrade the streams rapidly, eroding the banks and the bottom, and sandblasting the organisms that live in the stream, just eliminating them from their native habitat on the surface of rocks. In the following leg of a flood event, the sands that are suspended get dumped everywhere and suffocate the organisms and simplify the habitat so that virtually nothing wants to live there.
The Metropolitan Sewer District is on the verge of a very large program to reduce the combined sewer overflows into the Mill Creek. And this is going to be a huge event as far as pushing the Mill Creek to a new level for clean water.
We've had 2 or 3 supplemental environmental programs generated by the current consent decree with the US EPA to stop or curtail combined sewer overflows. And those 3 are a hike and bike trail and river channel improvement. The other one was to eliminate a fish dam at Hopple Street Viaduct so the fish can migrate upriver. And the third one was the removal of a cement bridge causeway below the Western Hills Viaduct. The industrial and natural areas in the Mill Creek are quite obvious to a canoeist. It's the easiest way to see them. The industrial sections are channelized by the Army Corps, what we call a trapezoidal channel. They're about 30-degree slopes on the sides and usually a cement bottom. Very, very sterile, and usually surrounded with old factories that go back in Cincinnati's history. What we're talking about when we talk about natural areas is whether or not we have regrowth of vegetation and riparian zone that allow native organisms to come back to the river. And even in some of the channelized reaches, that goal has been attained. Particularly the lower 1.7 miles of the Mill Creek is an amazing location. There's probably more wildlife there than you'd see in any comparable section of river anywhere because of this compression of habitat. It's an amazing facet of our ecology that what we do on the land, impervious surfaces, pollution, yard waste, everything works its way into the stream, and the stream integrates the quality of our environment more fully than any other aspect. And because what we do on the land impacts the water, the Clean Water Act is moving up onto the land, and it's having impacts now on what we do on land surfaces, as well as what we do with the water we actually take out and drink and put back into the rivers.
I don't think anybody can say they haven't polluted.
Everybody pollutes.
I have never polluted water. I believe I pollute water all the time.
The Federal Safe Drinking Water Act was adopted by Congress in 1974, and what it did was it required US EPA to develop health-based standards that public water systems had to meet. We as a state have adopted those standards as well as other standards, and we enforce the Federal Safe Drinking Water Act law in the state of Ohio. About 67% of Ohioans get their drinking water from groundwater.
Groundwater is the water that we find in the subsurface below the ground. It literally accumulates in large areas we call aquifers. Water systems or aquifers can be very, very large, and it can stretch out into the cities and the villages that we live in. There are several ways that groundwater can be contaminated. It has a lot to depend on what we would call the susceptibility of the aquifer. If it doesn't have a layer of soil that can adequately protect it, then we have to take measures that are more stringent in terms of our overall protection.
Ohio EPA does many different things in the state of Ohio to protect groundwater. We work with other programs within the agency to ensure that hazardous waste facilities, solid waste facilities, air facilities have protections in place to take steps to protect the groundwater so it doesn't become contaminated. We also have a program that works with facilities once the groundwater has been contaminated to remediate the problem to address the groundwater contamination.
We not only want people in communities who are using water from a specific water supply to be cognizant of protecting their water supply, but we also want industries to be cognizant of water supply. Water supplies, especially underground water supplies, if they become contaminated by a man-made contaminant, it may take many, 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 many years for that groundwater to clean itself.
In March of 1951, the Atomic Energy Commission found this small rural area northwest of Cincinnati and assembled 1,050 acres by eminent domain to create a feed materials production center, otherwise known as FERNALD. At this plant, thousands of people worked to purify uranium. This uranium was then sent to other places to create nuclear weapons. Through years of production, making uranium, thousands and thousands and millions of pounds and hours, contamination creeped into the aquifer through sand, gravel. It was on the soils. Remember, they were production first. There was no environmental movement. And by that way, sitting on top of this aquifer, the aquifer became contaminated. Uranium was underneath the ground in the aquifer. Uranium is a radioactive material. So when it shows up in wells, it could be hazardous to health if consumed in large quantities. The site shut down. In 1989, they said, we are no longer producing uranium. But then what? Okay, now what? We have to clean it up. How do you clean it up? And this was really unprecedented in all of the nation. And it took years of meetings. There were years where we had over 70 public meetings for the citizens, with the help of the community, the government, the regulators, which is the Ohio EPA and US EPA, and even just the fence line neighbors. All those people came together and finally came up with solutions on how we're going to clean that up. Initially, the people were given bottled water to drink until they figured out what was going to go on. The people also eventually got public water supply. Many of the people there were using wells for their drinking water. It was a rural area and that was commonplace. The groundwater supply is actually still being remediated. It's the one last thing that is continuing as far as a cleanup remedy. It's actually a simple process. We have 23 extraction wells. They pull the water up from the aquifer, send it to a treatment plant, and it's simple ion exchange. We can extract the water, pull the uranium out, hold the uranium, and then send clean water out to the river, which is very close, Great Miami River. And the water has to be at drinking water standards, which is 30 parts per billion. It's hard to model out, but it looks like the cleanup could go on to as long as the year 2023. The FERNALD Preserve is a legacy to the people around the area. It's a legacy from the ancient people who were there, the people whose wells were contaminated, the people who fought to clean this place up. And now the FERNALD Preserve is a nature preserve with an emphasis on wildlife. We will continue to monitor it, look after it, take care of the water as long as we need to. But it's a lesson for people that anyone who has an issue in their own backyard can make a difference. And I know that FERNALD was cleaned up to this level because our community got involved. I give them a lot of credit.